today's video, we'll be taking a deeper dive into stock market anomaly detection. This kind of project allows you to identify the unusual spike or the unusual behavior in the stock market, such as on the spike or drops in the stock market, or in the commodities you're looking at, or some of the equities that you have in the market. This can potentially lead to some opportunities opening or some identification of risk falls before they actually happen. If you identify the trends early on, you can exit the market before this kind of risk become manifested. In some other cases, you can grab these opportunities to make some better decisions or stay ahead of the game before the market go turn around. Why don't you go over to the architecture section where we discuss the individual components that makes up this stock market anomaly detection solution. In this architecture, we have Detector, which is the data provider, which streams data into Kafka. And from Kafka, we have Quix Streams, which acts like a consumer from here and streams data back into Kafka, which can be listened to on the visualization dashboard. In the real sense of it, if you drill down a little bit further, we have Detector, which has NASDAQ dataset. You can also use CME Globex MDP 3.0 or Detector Equities Basics. But in this video, we'll be sticking with NASDAQ dataset. Now, we have a Python producer, which is going to be managed overall by Quix Streams. This is going to be providing the data and producing them into Kafka. Now, with these streams of data coming into Kafka, we have Quix Streams listening to these events that are coming into Kafka, and from there, writing back to Kafka as swiftly as possible. Now, we can also connect this to Streamlit dashboard or Elasticsearch visualization dashboard, where we can visualize in real time what's going on in our dashboard. So the next step will be to go into Detector and get in the data set that will be used for this video. So I'm going to switch over to my browser, and on the browser, I'm just going to bring up Detector. So it looks like this. And with this, if you land into the Detector website, you see something like this. You have to sign in, of course. So once you sign in or register if you don't have an account, once you do that, you have something like this. Now, we're not going to be using the live data simply because you need to get some questionnaire and all that and other information. But we're going to be going into the NASDAQ Total VYTCH. For those of you that do not know what NASDAQ is a stock market index that includes almost all of the stocks, so the major stocks you can think of in the NASDAQ stock exchange. This includes something like Microsoft, Google, Tesla, Nvidia, and so much more. Okay, so in this case, we go into this data set and we can view that. Now, this provides us with a lot of data sets that we can use in terms of products, which has about 19,000 products and in the equities list here. But we're not going to be, using all of them. We're going to just use the Nvidia at the top here. So once you select Nvidia, which is the first one here, once you select that, that gets added to your cart. Now, it depends on when you want the data from that gets you the number of charges you'll be having. So let's say we start from a month and I pick up 1st of August, yeah, to the 30th of August. Yeah, or better still, yeah, we can just do the last month, which is starting from August 14 to September 14, which is good. Now, in this case, once you select that, you go into the customized download, and that's going to cost you $5. You don't have to worry. You're not going to be paying for this. Once you sign up, you have about maybe $200 worth of credit that you can use to download this sample data set. Okay. In my case, I'll be using the the CSV for the data set. You can also use the Detector binary encoding or JSON, but I'll be selecting the CSV in this case. Now, which compression method do I want to use? Z standard works fine, so it's very fast and lossless compression algorithm. So I'll be using Z standard for that. Which delivery method? I'll be selecting HTTP and FTP. So I'll submit the request to that. And this is going to queued, and $5 will be gone from my credit. So it takes a few seconds to get this done. But once that is done, you can go into the download center to see the data. So this is still queued up. We wait a few seconds for that to be done and we continue. Okay, so the data set is ready for us to download, and you can go into this data set. You have the ability to download via HTTP or via FTP. So we're going to take a pause on this before downloading because we'll be using the FTP. So we just need to get a folder where this is going to be sitting in. So I'll be going back to my project and get a project ready so we can get started. Then we download this data set where we can bring it into our project. So I'll be creating a new project. I'll call the project, I'll call it Anomaly Detection. So I'll just bring it here and start with Anomaly Detection. I'll just say Quix Anomaly Detection. Okay. With this, I have a Git repository added to the application, which is creating Git init. If you are using any other IDE, then you have a welcome script, which is like a sample file to get you started. Then you have the Python version, which is Python 3.9 in my case. So I click on create, and I wait for PyCharm to do the initial bootstrapping and get it started for me. Okay, so with this, I have the initial file created for me, and I can start with the terminal. And in the terminal, I need to get my dataset folder, which is where I'll be putting the dataset. So let's create a folder called dataset. You can call it whatever you like, or NVIDIA or whatever. I'll be using dataset in my case. Or to make it make sense, in fact, I'll just change this from dataset to NVIDIA, okay? Or not NVIDIA. So let's use NASDAQ, okay? NASDAQ dataset, because if you select multiple files to be inside that, you might not have only NVIDIA in that case, but NASDAQ looks more generic, so it makes more sense. Okay, so with NASDAQ folder, in this case, I just need to go to my FileZilla. Okay, so that's Quix Anomaly Detection. And in here, I have the NASDAQ. So with NASDAQ, this is where I want the data to go into. So I need to get in my credentials for the SFTP to pull data into the system. So let's go back here, copy the URL and paste it here in the host. And in the username, I copy my username from here. And then the password, I'm going to put in the password as well. Hopefully that's correct. Yep, I'm logged in, and now I have the data. This is XNAS, which is 240914, and in here I have all of this data, which looks like this, which is good. So I can pull that into NASDAQ. I'll select everything and drag them over to NASDAQ, and that should be fine. By the way, if you are using any other operating system, FileZilla is multi-platform. It's a cross-platform application, so it should work just fine if you follow the steps. All right. Now, while this is going on in the background, we switch over to this application, and we don't need this main.py. It's just for show. And once that is done, the next thing is to get in our application, which is the orchestrator, which fuses everything that we'll be using in this video, fuses them together. That's a Quix CLI. So Quix CLI is a library that is provided by Quix, and I'll just pull up the documentation for Quix CLI, and now you can get it started. So for you to get started, you can go to quix.io/docs or quix.io, and you can get to the docs section. So in the Quix CLI, you go to the overview section, you see how you can get it started and how it works. But we'll go into the quick start to get the installation started. For some users that are using Mac OS, Linux, or Windows, you have to select the right operating system to be able to use the right command. So if I copy the Mac OS and I go in here and paste it here, I already have it installed, but it's just going to update the installation. So just going to install that, and Quix CLI is installed. So you can verify that by typing Quix status. If you type in Quix status, you should be able to see I'm not logging to Quix Cloud. The current context is this, and it has a Git and the Git root, which is good. So, but I have a Docker as well. So all this is fine. So if you have something like this, then you're good to go. So you don't have to manually do all of this. So everything is working just fine. You might be wondering why I decided to use Quix in this project. Quix allows you to have a couple of functionalities out of the box, something like stateful operation. So if something goes wrong in the system and it shuts down, so anytime it restarts itself or you restart it, you don't have to reprocess what you have processed. It continues from where it stopped. It has exactly once processing, which means that you don't have to worry about multiple reprocessing of the same data that has already been processed. Unlike some systems where you already process some data, you have to start reconfiguring to know where the data is going to start from again. It always gives you a guarantee of exactly once processing. Also, I decided to use this in terms of the data sync, which is where you can write a custom sync classes. You can decide, just like in our video here, we can decide to write into Streamlit, Elasticsearch, Postgres, or a variety of other data syncs that you want, which is like custom. You can also leverage some of the libraries that they already wrote, so you can just refactor those, and it works just fine for you and for your use case. And finally, it's majorly because it's pure Python. And this is simply because the Python community is great. So it's the code is easy to understand and easy to integrate with any other systems that you want. You can also use it for any other use cases that leverages fast data. So let's go on with the Quix CLI and continue the discussion with that. So what it does is each of the components of this video or any projects that you want to do will have a separate application which you can scale up or scale down as much as possible or however you want. So in our case, we are going to be having a producer, so which is separate from the anomaly detection engine. Okay, so the producer, if you have to produce heavy compute, you need to increase the compute power of the producer. The same thing happens in the anomaly detection part. If you need to crunch a lot of data, so you need to increase the compute power. But if you don't need much compute for any of the application you'll be connecting in the same general application, you just need to use a simple compute. So let me show you how that works. Okay, so we start with a simple one, Quix app create. Now it's going to ask you if you are going to be using the empty, the status source, transformation, or the sync. So in our case, we'll be using the status source. But before I do this, I just missed a step. I should start with Quix init. So Quix init is going to initialize Quix in your application. So in this case, you have the Quix YAML, which is the YAML file that that is majorly managed by Quix. This describes the deployment and the topics that are used in your Quix project. Okay, once this is done, you go then to Quix app create. All right. So with the Quix app create, you start with the status source, okay? So which asks you where the data is going to be coming from and where it's going to be going into. So the application name is going to be producer. I call this producer because this is what produces the data. So the output of this, which we are going to be writing data into, is going to be a new topic. Okay, the topic name is going to be stocks. All right. So here we're going to have a folder called producer, which has its own Docker file and some requirements that will be used for this particular producer. Now, if you look at the Docker file, it's something like this. It's as simple as that. So this is the Docker file for that. And in the main section, it has a simple bootstrap code that we can leverage when we are producing data into Kafka. So in our case, we just need to refactor this to suit our use case. But if you want to test this out to see if it is actually working or not, you can just run this as is and you'll be good to go. So in this case, if I want to test this up, I just do Quix pipeline up. If I do Quix pipeline up, so it says it doesn't have any deployment, so it's going to try and generate a deployment for me. Okay, and you can see it generates a compose locally.yaml. So we has a Kafka broker and the console. So this is a win for people that do not know how to set up the Kafka broker or Kafka console. This uses Redpanda, by the way. So all the configurations for the broker is done, so you don't have to manually do that. So if you look at this, you see that your broker and the console ready to rock and roll. And let's see what that looks like if we go to localhost 8080. Okay, if you go to localhost 8080, you see your broker that is running and you see the topic. So nothing is here right now. If you go to the Docker dashboard, you see that you have, I'll just drop this down. You see that you have your Kafka broker and you have the console. So if we go back here and run this, this is going to be producing data into our environment, which looks like this, .env. So it's using localhost 19092. All right. So if I just do Python, so I'm inside the anomaly detection, I can go into producer and type in python main.py. So yeah, I need to install because I'm not using, I haven't packaged up the producer yet, so I just need to install the requirement. All right, so once the requirement is installed on my local system, I can easily run from my local system. Okay, so if I run this again, python main.py, so this is going to produce all this data into Kafka, and you can see what that looks like. Okay, if I refresh this, you see that I have stocks, and in my stocks, it looks like this. So all the data that is pre-filled or pre-bootstrapped with the system, you see them here. All this, you see that data here. Okay, so that means our main application is working just fine. We can get started with the rest of the system. Okay, so the first thing we want to do is to adjust this data to suit our need. So we'll be pulling our NASDAQ data set into producer because only the producer needs to know what NASDAQ data set is, read data from there and send it over. So it looks like this. So it's going to be ZST and all that. Okay. So we need to add to the requirement, we need to add Z standard. Okay. Which is going to be the additional requirement. I'm just going to disable completion here. All right. So the Z standard should be fine there. And in my main.py, so we need to read the data from NASDAQ. So I'm just going to adjust this part. So instead of getting the data here, I'm just going to read the data from that folder. Okay, I'll use glob for that. So I'll just bring in glob. So import glob. And from here, yeah, I'll just remove this. I'll say files equals to glob.glob. And then put in the directory where the data is going to be coming from. That will be NASDAQ and anything that looks like ZST. Okay, so asterisk.zst. So that's what we are going to be reading from there. So I need to sort this so the data can be produced sequentially. So I just sort this, ascending order. Now that makes sense. And finally, we need to bring in something like a reader. I prefer to use TQDM for that. If you prefer, but this is like optional, so I'll just use TQDM. All right, for the requirement. All right, so for the files, I just need to do for file path in tqdm.tqdm. I need to import tqdm. Yep, import tqdm. Okay, good. TQDM. All right. Okay, yeah, TQDM, and I just need to read the files from here. So I have all of the files, all of the file path that will be printed out. So the next thing is to print them out, or print the file path before we produce, so we know for sure we're doing the right thing. So let's see what that looks like. If I just print file path and I run this, pip install, yeah, and I just run this. you should see that we have all of the data, and is ordered sequentially from the August 14th to September 13th, which is good. So the next thing is to now proceed with the production of the reading of the data and then production into Kafka. So we have let's just say printing out here. I just have processing file. Which file is that? The file path. Good. And then we just need to do data equals to PD, which is pandas. We don't have pandas in the picture. Import pandas. And I just need to put pandas in the requirement, so I know this is the requirement for my producer. I just need to install the requirements again, so I don't have errors or scribbles on my system. Okay, so here I just say import pandas as PD, then go back to the PD and just say read CSV. Okay, file path. Now we're going to have a problem here because it's not direct CSV. This is a Z standard CSV. So we need to bring in Z standard. Oh yeah, we already did. So there won't be any problem. But if you don't have Z standard installed or added to your requirements, you're going to run into challenge when you run this system. Okay. So once that is done, the next thing will be to we've read the data into with pandas. Now the next thing is to run the data from that pandas data that has been read. So I just have for row in data.iter rows. So this gives me like individual records, right? I can have my trade is going to be row.toDate. All right, so this converts them to key value pairs. All right, and I have JSON data, which is what I had here. Can use the rest of the code here. Just uncomment that, and that will be trade. Okay, so this converts to JSON, and I can produce that. But I need to change this from row data to JSON data, and I need to change the data to symbol. Oh yeah, by the way, you may not know what the data looks like. So if you just do data.head, you should be able to, and I break this, so I don't have to read everything. Yeah, so you should see the first 5 records and what it looks like by the time you want to run this. Hopefully that works just fine. Good. So it did work fine. We are not seeing that, so let's say print data.head, and I just rerun this. Yeah, this is what I'm looking for. I'll just reduce the font size a little bit so it's easy to see everything at a glance. So you see that we have a symbol called NVIDIA, and we have all the other data in here. So we just want to use the symbol as a key for production. Okay, so that's why I used the JSON data symbol in this case. Okay, so I don't need this anymore. I have my JSON data and the symbol. So for each of the record, the symbol is going to be the key, and the value is going to be deserialized. It's going to be serialized into Kafka as a JSON object. So that's good. Well, we can take this for a spin and see if everything works fine. By the way, this is just making our code bulky. We can remove this part. We don't need that. And by the way, you have the topic name, which is good. I think everything is fine at this point. So you don't necessarily need to do anything anymore at this point. So yeah, but I think that would be it. But finally, I think if you had a problem with your broker, I think because I'm running outside of the Docker container, you might need to put in a broker address here, so to prevent issues. And to get your broker address, you need to go into your Docker Compose. In the Docker Compose for the broker, you have the Kafka address, the internal, so which is this, and the advertised Kafka address, which is internally is listening to this, and externally we are listening to this. So if you look at what we had in our environment, so this is using the external address. Yeah, that's what it's using. So we need to update this so we can run that in our local system, in our Docker container, and I'll change that to this. Alternatively, if you don't want to change anything here, you can leave this as it is and just put in your broker address here. So it works just fine both ways. Okay. All right. Now that this is done, the next thing is to take this for a spin on the Docker. So by the time Docker spins up, it automatically runs the producer and starts producing to Kafka. So that's what we want. Anytime we start our project, read through this NavDAC data set, produce them, all of them individually into Kafka. And we can listen on the anomaly side of things to get things working. Okay, so once the producer is initialized, the next thing is to update our Quix YAML, so we know what we have and what we need to do next. So we can do Quix pipeline update, and in this case we have the Quix YAML will be updated. The secret doesn't have any change. So if you look at the deployment here, we have a producer which has the CPU resources, the memory, and some of the variables that will be used, which is the output topic, right? And the topic in this case is the stock. Now, interestingly, if you need to increase the resources that need to be assigned to the producer, all you just have to do is go into the resources section, increase the memory, increase the CPU, and you're good to go. I believe there are some parameters that you can use to generate a producer, but we're not going to go into that with the custom resources. But if you need to manually go into the resources section, you can update that in the CPU and the memory part. Okay. Also, you can increase the replica as well. Okay, so that's good. So the next thing is to Quix app create, and we create the next one. So the next one is the transformation part, which is the anomaly detection. So I call this anomaly detector. All right. And in the anomaly detector, so the input topic is going to be the stock, and the output topic we need to create one. So let's call this anomalies. All right, I think you're getting the gist, but in the case you are still like unclear. So if you need to work with transformation is in the middle of the source and the sink, which is like source and the destination in the middle. So if you work with the source, you only have an output. So you produce data and you have an output. But if you work with transformation, you have a source and a destination. If you work with the sink, in this case, you only have the input. You can also have the output if you like, but most times you just have only the input in this case. All right. So that's the gist. All right. Okay. So once we have the anomaly detection, the same thing happens here, with the exception that this is now a transformation. If you look at this, the consumer group is just, it changes. And this is like intelligent enough to do that. And you have the ENV, which is the same as before. You have the main. Literally everything is the same, except that the structure of this is to have input topic and the output topic. So you can now do your transformation in the middle of that. Okay, so let's get in our system. But before we go dive into that, I need to just give you what we're going to be doing in this particular part of the anomaly detection. So anomaly detection is just to find outliers in the system, things that looks out of ordinary. So we can apply as many transformation logic to get the anomaly detection, including developing a model, which we'll be doing in this video. But in the case where you have multiple anomaly detections algorithms that you want to develop. So for example, if you have a model that is helping you to do the anomaly detection inference, you need to have, I would recommend you have a separate application for that, which does the transformation for that particular anomaly detection. But in some cases, you don't have every workload, so everything can still work just fine. So we're going to be implementing two rules in this system, one with isolation forest, which has a model. We have an isolation forest model, which we'll build in this video, and then we infer, as the data is coming into the topic, we infer with the isolation model to see if this is out of ordinary based on the trees that we've already have in the system and the historical prices. Anything that stands out of ordinary will be flagged in that case. The second bit is to have a very high price, so for the stock. So for example, if you have on a normal day, let's say 100,000, let's say that's the maximum limit for a corporate business or something like that, or anybody that wants to trade in the stock market. For some reason, you see somebody placing 150,000, 200,000, £1 million rec or dollar or whatever the currency is. They are placing it on the stock market for a particular stock. You might want to flag that up and see what that particular person is trying to do in that case. It may be genuine case, it may not be, but that would be like a a place to start the investigation from. Okay, I hope that makes sense. Now let's go over to the coding section and start the implementation. So let's go over to the code and get you started with that. So now in the anomaly detection, we just need to adjust this. We're going to be using the isolation forest, so we need to bring in scikit-learn. Scikit, yeah, I'm right. Scikit-learn. Yeah, that's the first one. Good. So that will be what we need to bring in the first bit. Import sklearn, import sklearn. Sklearn has a library called isolation forest. So we should say for from sklearn.ensemble. We're not seeing the IntelliSense because I have not installed the. Yeah, let's get back one step and go into the anomaly detection, anomaly detector, and then pip install the requirements, and that should install the anomaly sklearn for me, which I can get the isolation forest from. Okay, so import isolation forest. You see that IntelliSense picks up. Good. Now, once that is done, we have our .env, we have sklearn, we have Quix Streams. I think that's it. If you need anything else, we can always bring them into play. All right. But for now, let's stick with this and get the application up and running. So transformation is here. Auto offset is the earliest. Then we have a broker address. Okay, broker address, which is going to be coming from this guy. We'll be using the internal here, and I'll put this here as well. Okay. All right. If you need to format, just right click and reformat code. Optimize. Good. And yeah, everything seems to be okay. And I can just break this down to, yeah, we have interesting piece here. Good. Now the next bit is going to be our input and output topic, which is good. The next thing is to go into our code and scroll down a little bit into the main. So we have our main here, which runs the data frame. So we have a streaming data frame here. Just bring this here. So the simplest way to work with Quix is to have, just like you usually work with pandas or Apache Spark, you have your data input into like we read that into like a data frame. From there you now do your manipulations. Once you are done, you can do whatever it is you like with the data frame that you've transformed. The same thing happens with Quix as well, but in this case they call it streaming data frame. So once you listen to a topic, you create a data frame from that topic, and as data comes in, it's going to come into that particular topic, which is called streaming data frame. Then you can now start applying your logic into to that particular data frame. Eventually, you can now write that particular streaming data frame to topic. Okay, so in this case, we have app data frame, which reads data from the input topic, and here we can now apply our logic into this streaming data frame. Okay, I hope that makes sense. Yeah, so let's see how that looks like in real practice. We're going to have SDF. It's going to be SDF. Just put this in because we're going to be applying multiple logic. So SDF dot apply. So I'm going to start with the simplest one, which is going to be the iVolume rule. iVolume rule. Okay, iVolume rule, which is going to be a function, right? So then if you have another one to apply, you just need to do apply and put that into that as well. But let's start with the iVolume rule. So let's create a function called dev iVolume rule. All right. So in this iVolume rule, we need to put in where is it? iVolume rule, and we need to read the data. So it's going to send this data as a dictionary into this function. So we have let's say the trade data. So what happens is with this iVolume rule, we have the dictionary of this particular trade that is going into the topic. We have it here. So the next thing is we want to check if this particular trade is having a very high size. Okay, so let's see what that looks like. We're going to have a volume threshold. So let's create a volume threshold just above here, and that will be the iVolume threshold that we'll be using to say anything above this is called iVolume threshold. So let's say iVolume threshold. That will be our default dictionary, and we can bring this in from collections. All right, default dictionary, and that will be the lambda of 20,000. All right, so you can increase this if you have a higher volume threshold, but I'll just put it at that. Then once you have this, the next thing is to now put in the logic for the high volume threshold. In this case, we're going to be saving if this particular trade is going to be a high volume anomaly. So let's call this high volume anomaly. All right, it's going to be a boolean which we are trying to convert from. So we get the trade data and we get the size from there. Size. Now, if the size is greater than the high volume threshold of our trade data, all right, trade data symbol, okay, symbol. If I can only type symbol, yeah. So what this means is you are checking the trade size and seeing if that is higher than the volume threshold of that particular symbol. This means as simply as if you have multiple symbols that you're tracking, you can change this particular default dictionary in here. Instead of using 20,000, you'll be using something like the symbol and then the value in that default dictionary. Okay, so but in this case it's going to be as simple as that. So we have trade data and eventually we just return trade data. All right, scrolling down, I think we can take this for a spin and see if everything works just fine. Yeah, so eventually we run this into the topic. Once you apply this, it's going to see high volume anomaly attached to this particular data frame, and we can use that to write into a topic. So let's see if this works just fine. Quix pipeline update to update the Quix YAML, and you can see we have Anomaly Detector here as well as a service. So the next one is to Quix pipeline. Hey, if I can only type that. So we have the broker running and it's trying to build in our producer and the anomaly detector. So let's see if that works just fine, or we need to change anything else. You can also see the running, just the logs here, or you can go into your Docker dashboard to do that. But we just wait for that to be done and build the. Okay, so our producer is started and the anomaly detector is also started. If you look at the producer, it says JSON data symbol, indices must be integers, not string. So the key is reading this as integer and it's not reading it as string. So let's see, string indices must be integers. Let's see what's going on over there. If you go to the producer and let's see what we have. Okay, if you look at what we have in here in the producer, we are using the dumps of this particular trade data, and that's why we're having the issue. So instead of that, we should use the trade, not the JSON data. So we should use the dictionary here. This is like already dumped into like a JSON format. So we just need to, because that's what the value looks like when you're serializing into Kafka. So this is helping us to do the serialization, but we use the trade data in this case. So I'll just go back here and Quix pipeline up again, and that should rebuild that. Okay, so if you go to the producer, it's not stopped this time around, and you can see it's processing this file. So if you go to your dashboard on Redpanda and you refresh this bit and go into the stocks, and you can see 128,000 record has been produced already. If you see this, you have 163,000 records, which is good. So that means the production is going on in the background, and there the anomaly, we have some interesting records here. You see the high anomaly is false, so that means it's writing everything that is coming into the producer into the same anomalies topic. Meanwhile, what we want exactly is to be able to write only the anomaly records into this guy. So that's what we need to fix. We don't need to write everything into the stocks and this anomaly at the same time. So I'll just go back here and then Quix pipeline down. Okay, so the good thing is we're able to see the producer and the anomaly detector working as we expect. Okay, so the next bit is now to finalize and make things more reasonable, because we don't want to be writing. So what this is just doing is checking if the particular trade is high enough, above 20,000. It stamps his anomaly to that as a true. But in the real sense of it, we don't want to be writing everything into the anomalies. Only the anomalies will be needed to be written into that particular topic. So let's fix that bit. Based on this, we don't need to do anything in the production. So let's go to the anomaly detector. We can leave this as it is. We are going to write a function that helps us filter that out. So let's create a function that helps us create the anomaly isolation forest. So we have apply, and then we're going to be applying the isolation forest rule. We call this a function called isolation forest rule. Isolation forest rule. So this will be the rule that helps us to create a model and then maintains the model in the system. So we have a isolation forest rule, which is going to be the trade data to be coming into the picture, just like we have in the I volume rule as well. So we have this trade data. So let's quickly get in our model. To do that, we have a global is fitted. And in this case, we have is fitted as to check if the model has been trained or not. All right. So let's extract the current price, which is going to be the trade data, and then we pull in the price from there. Good. So then now the next thing is to now have like an array where we're going to be pulling all these prices that will be used in this case. So we just above here, let's pull in the field prices, which is going to be like a list of prices that we're going to be working with. Let's pull in the is fitted. It's going to be false as well. Good. So by the way, this is just to check if the isolation forest model has been trained. All right. And for this guy, we use this to collect the prices to fit into the model. Okay, so this is going to collect all the prices that we want to use to train our model. Then anything above this or like that goes beyond this is going to be outside of this particular scope. Okay, and we can flag that. So the fit prices append, and we just convert this to float and just extract the trade data current price. Okay. So what we're trying to do here is to say anything in the space of 1,000, in the first 1,000 records, will not be used to train will be used to train the model and not to infer. Anything above 1,000 will be used to infer. So, like let's say fit price is normalized. It's going to be numpy, which is let's bring in numpy as well. Where is numpy? Do we have that installed already? I think when we install pandas, numpy comes with it by default. Buy one get one free. NP. All right. So we can say np.array, and we fit our prices into this. Fit prices. So the way we try to do the normalization is to get the array of data from the fit prices and get the mean, subtract the mean and over the standard deviation. That's the simplest way to do the normalization. Fit prices, and then we can divide this by np.standard deviation, std.fit prices. So the array minus the mean over the standard deviation. That's the normalization function in there. So we have the prices reshaped, so which is what we now need to use to train the model. So we need to reshape this fit prices normalized to reshape this in -1 to 1. So this reshapes the data, and we can use this to now train to train the model. So if the length of fit prices fit prices percentile 1000 is equals to 0. So that means at every 1000 we need to retrain the model to recognize the new prices. Otherwise the system will not recognize them. So we need to make sure that each time we reach a checkpoint of 1000 records in the system, we retrain the model, or if you want to increase this maybe to 10,000 to 100,000, however you want it. But in my case, every 1000 as a checkpoint, you retrain the model. And this is simple. There's a simple logic behind this. If you and your friend goes into a supermarket and your friend is so good at identifying the items in the shelves, so if they do not keep going into the supermarket, they're not going to keep updated of where those items are going to be. So by going there regularly, you keep updated of the prices and the location as well. In a case where the management decides to update the location of those items, if your friend do not go into this supermarket again, they are going to lose the location and the prices of those items. So by constantly going there and retraining themselves, they identify that. That's exactly what we're trying to do with this model as well. So at every 1000 checkpoints, we check the prices again and use that to retrain the model to say these are the new set of prices and these are probably the new location of these items in the shelf. And then as a result of that, we check that and make inference. Okay, now we have isolation forest, which you need to create. So let's create an isolation forest model, which will be used in this case. So let's just at the top of this code, I need to scroll up. Yeah, just at the top here, I just need to create an empty model here. So the empty model is going to look like this. Isolation for forest is going to be isolation forest, which we just brought in, and we get in our contamination. So let's say we are expecting a contamination rate of 0.01. That's like 1% of the data we expect to be contaminated. It could be more, it could be less, but let's start with the contamination rate of 1%. So the number of estimators, this is the number of trees that you want in your forest. So the more your trees, the more robust the system is, and it could make better inference. But what that also means is the more the compute. All right, so I'm going to limit it as 1000, but in the real sense of it, you want to increase the estimator size to as big as possible, but you need to now have a dedicated compute to that. Okay, so I have my model, and so I have the fit prices, I have this fitted, I have the isolation forest. I think that would make more sense. We can get started with this. If you need to add anything, we can continue with that. Isolation forest. So we need to now, train the model to identify those prices, and then we have prices reshaped. So we just trained the model with these prices that has been normalized here, and is fitted. Is fitted will be true. Okay. So isolation forest is there, which is good. We just trained the model. So let's get into the picture now. If not, it's fitted. So if you have not fitted the data, so we have trade data. I'm putting isolation forest anomaly is going to be false. So that means there is no, we didn't train this data. This particular record is not part of the training data, and we just return trade data. But in a case where we use this data for the training, then we need to get in the current price normalized. All right, current price normalized. Okay, so we get the current price minus the float of np.mean, just like we did before, of the fit prices divided by the float of np.std fit prices. Simple as the same thing as before, really, with the exception that we need to, it doesn't have to be, it has to be like this. We don't need that. Good. So it has to be current price minus the mean divided by the standard deviation. That gives us the current price normalized, and then we can use this to infer. Now we train the data, we want to do the inference, and the inference is done as such. where you have the isolation forest or decision function, and you pass in a double square array of current price normalized. And it's simple because we did a reshaping of this data earlier. So for the inference to be done, you need to get that into the same structure as well, and that gives you the score. Now, anomalies by default are identified by negative scores, but if you have a positive score, then it's not an anomaly. But if you have a negative score, then it's an anomaly in this case. So let's check that. So our trade data is going to be isolation forest and no anomaly, right? It's going to be a boolean score, boolean score of less than 0. All right, so what this means is a boolean score 0. Yeah, we said the record in the score, is it less than 0, and it's simply, let's put this here, anomalies are indicated by negative scores. Okay, and then we can return the data, trade data. Again, to quickly run through this again, we get in the price, right? Then we fit it into the list of prices that we've identified. If anything is less than 1,000, we are not training the data with that. But if it is above 1,000, we get the normalized function, reshape it for the fitting, and then every 1,000 milestone, we retrain the data. But initially, we just go straight into this, and if we have fitted that data, we return the false if we have not fitted it. But if we have fitted it, we just go straight into this and evaluate that particular trade to see if it is anomaly or not. So that's usually with the negative score. So if you have a negative score, then it's an anomaly. Otherwise, it's not. Okay. And that's what we need to do here. An isolation forest rule is good to go. So the next thing is to now have a simple function that helps us to combine those two together. So just say combine anomalies, and this is what we apply as a third part. Apply combine anomalies, which gives us the same trade data again. Could be anything that you want. So we have anomalies. It's going to be an array, and if the trade data and we get the let's use the get function. So you get the I volume anomaly. If that is I enough, then we say anomalies dot append I volume, and then if again trade data for the second rule, isolation forest anomaly. I'll just copy this, paste it here. If that is existing in there, then anomalies dot append isolation forest anomaly. All right, so that's taken care of. So we just check if we have anomalies, we append this to the trade data. If not, we don't. So we have trade data and we say anomalies. It's going to be anomalies if anomalies else none. this sounds the rhythm really hits hard. Trade data. So as simple as this looks like, if you identify high volume anomaly, attach that to the anomalies list. If you identify isolation forest anomaly, attach it to that. So you can see from a particular trade, if that particular trade is having, if that particular stock itself is having multiple, is being flagged by multiple anomalies, maybe high volume anomaly and isolation forest anomaly in our case, that is going to be attached to their list of anomalies. Otherwise, if it is just one anomaly that identifies that particular, say that again. If that particular record is identified by a single anomaly, right? You have a single record in the anomalies list. If it is more than one, you see two records. If you have multiple rows, you can add that to the list of anomalies. So that makes sense. Okay, going back here, we have our data, which is the final one. I think, yeah, that's all we need to do here. Now, the last magic that we need to perform here before we write into the topic is to filter out only those anomalies. Then we can write into the output topic. So we just say, let me just put a comment here so it's easy to read. So we say filter out only rows where 2 anomalies or more are detected. Only rows where 1 or more anomalies are detected. Okay, so we have sdf.filter, and then we put in a lambda in here, lambda. Okay, and the lambda is going to be a row, and the row is going to try and get the anomalies. And yeah, once we get the anomalies and we get the length of that anomalies, okay, length of row and anomalies, that would be, we try to get the length, and then that will be greater than or equals to 1. So if you have 1 anomaly or more, then we append that into the anomaly section. If not, we just we don't write that, so it's going to be empty. So we just say filter out the rows that has anomaly and the length of our anomalies is greater than or equals to 1. Good. And I think that's the only thing we need to do here, and that's the final thing that is keeping us here. So let's format this this document in our Anomaly Detector. For some reason, I'm obsessed with the formatting. Okay, it looks like that. Everything is working just fine, and then we just need to do Quix pipeline update. Pipeline update. Okay, no changes. Good. And then we just up this. And if you go into Docker, that should pick up. It's building that. So it's just created a broker. Let's see. Yeah, created a console, anomaly, and the producer. Let's see what that looks like. We have the broker, the console, the producer, and the anomaly. Good. And the producer has started, and you can see just off the bat you have 106%. So this is doing heavy stuff. So in real life, you might want to increase the compute power that is assigned to the CPU resources for the producer. The same thing for the anomaly detector as well, is working in the background. And if you go back in here and I try to refresh, so in the anomaly section, 296 records have been identified, and this is isolation forest anomaly. So there's no anomaly for the high volume, but in this case, we get some records for that. So let's see isolation forest. And it's simple. The reason why you have more records in this isolation forest is because any price that is above that particular identified anomaly is going to be reported. If you look at 116 here, the next one will be 116 or thereabout. So it's staying for a couple of seconds, and the size here is not that big. So anything that is above the identified limit is going to be identified. That's why you're seeing something like that. Okay, I think that makes sense. So the next bit could be going from here. If you look at the architecture we have the data being written back to Redpanda. If you decide to connect Streamlit to this, or Postgres or Elasticsearch to that, you can do the visualization from there. But as it is right now, we're going to be taking a pause on this. And if you let me know if you want the Streamlit and the Elasticsearch, we can incorporate that as well. Or maybe you want to write into Postgres in your own case. Before we go now, let's go through some of the documentation information that you have on Quix and how you can work with them. So if you go over to the Quix, in the Quix docs, you have everything you probably will need to work with Quix. So like the Quix Streams, the Quix CLI, and the rest like that. But in our case, we were working with Quix Streams. So I want to show you one thing that is cool that you might want to also use as well. So as part of the Quix Streams, you have, if you go into the Quick Start, you see how you can set up the system. But interestingly, you have the API docs here, so which is the streaming data frame API. So we have a lot of information here that you can work with in terms of what you want to use. One thing that I think might be interesting in this case, we already use the apply function You might want to also use or try something like the windowing capabilities as well, where you get in the windows into a particular time frame, or you have a separate store where you have a windowing. They have a tumbling window. Let's see, tumbling. So you have the tumbling window, you have the open window, and so much more like that. So if you want to use something like that, like the tumbling window, the hopping window, you'll be able to use them as well. But you have the documentation that is here, and you see some examples, so now you can work with them and use them as well. But in our case, let's take a pause on this, and so let me know if you want us to like go deeper into the additional sync like Elasticsearch. Maybe Postgres. Let's add Postgres to this, or even Streamlit. So we can do like real-time visualization of the dashboard as well, just like we do in Elasticsearch. If you look at what we have here, producer has stopped, and simply because the production is done. You can see TQDM shows you something like this, and you can see we started with the August 14th, and we have September 13 as the end date here, which is what we have as we expected in our data sets from Databento, which is good. I mean, you can see what that looks like also on the stocks. It's about 9.5 million or thereabout. And the stocks records that we already identify is 3,000 records. So that means if you want to have a consumer or some separate logic that helps you do something, you could decide to work on based on this. So maybe visualize these anomalies or something like that, or overlay what this anomaly looks like from the existing chart and identify those anomaly points. Yeah, that could be like what the next steps will look like if you decide to take this further. This video is courtesy of Quix Streams, and don't forget to join the community so you can ask direct questions to the team and they can give you straight to point answers on how and help you if you get stuck on any part of the video or any projects that you're working on using Quix Stream library. Also, don't forget to go into the documentation. There might be something that I didn't say the right way. The documentation is going to correct me and it's going to give you the right and accurate information. So thank you very much for watching, and I'll see you in the next video. Cheers.